Let's take a closer look at the ACR7000 and IPA hardware. For the 7000 stepper, there's a motion enable input on the IO0 that needs to be connected to 24 volts, which we offer on pin number 19. So if you just jumper it to pin 19, then you can make motion. So you can use that for an external circuit on the machine, or you can use a jumper right there on the connector. On the front of the 7000 stepper, you have the 4 motor connectors and the encoder inputs. It's a Tyco crimp style connector that goes onto there. It's keyed, so it can only go one way. Used with any standard two-phase stepper motor. 1.8 degree or 0.9 degree stepper motor is fine to use. The encoder input, standard quadrature encoder can be used. We provide a 5-volt output to supply power to the encoder. There's a status LED. It'll be off if it's not powered. It'll be green if it's ready, and when it's booting, it'll be red. There's 24-volt control input power on the bottom left, and on the bottom right you can input 24 volts for motors 0 and 1, and also motors 2 and 3. The default IP address is 192.168.100.1 and is user configurable in the software. The Ethernet port has a yellow link light that indicates that the connection is made, and it'll be flashing yellow when activity is going on. Green indicates 100 megabits per second. It'll be yellow or orange if it's 1000 megabits per second. The 7000 stepper I/O is up on the top. It's two 26-pin female D-sub connectors on there. Those inputs and outputs are NPN only, so it takes 5 to 24 volt. There are 12 general purpose inputs, which are shown here. They're the first 6 pins on both connectors. There are 8 high-speed trigger inputs, so there's 4 on each connector. There are 8 outputs. 4 can be used to fire automatically based on the position of the motor, which are on the first connector. There is an enable input on the IO0 connector. We have a 24 volt output. You can use that for external limit switches or a home sensor for powering transistor sensors. The 7000 stepper enable input is pin 17 on the IO-0 connector on the top. Pulling these will immediately kill all motion and disable all drives. It won't stop the programs from running, but if the program commands a new move while this is on, then the motion program will halt. Other programs could still be running, and an error recovery program can be programmed to monitor this. When the enable input is pulled, it sets the axis kill all motion request flag and sets the kill on all the masters, which are the interpolators. The DACs are forced to 0 and the step pulse generation is blocked. This is a similar design as the previous generation ACR9000. For the stepper wiring, for a typical NPN sensor, it's going to blue, black, and brown for the color codes. Black is your sensor input, and that switches it to ground. The brown wire gets connected to 24 volts, and that's powering the transistor within the sensor itself. And then blue is digital ground. all the digital grounds on the connectors are all tied together, so any digital ground can be used at your convenience. The 7000 stepper output, when you turn on, will switch to ground internally. You would still want to connect the grounds together. This is one example of an NPN input. The circuit may be different for other NPN inputs, but they work in a similar mode. So note the current flows into the output to low DC common, thus syncing the current from the input to ground.